So let us see this problem, chemical kinetics, and the topic is gas phase decomposition reaction, second part. So this is the problem. Following gas phase reaction, ether, dimethyl ether is converted into methane, hydrogen, carbon monoxide. This is a first order reaction. So it is carried out in a constant volume container at 500 degrees centigrade and has a half-life of 14.5 minutes. So initially only dimethyl ether is present at a pressure of 0.4 atmospheric pressure. What is the pressure total of the system after 12 minutes and assume ideal gas behavior? So we will solve this problem. So first you write this equation, CH3O CH3, this will give you CH4 plus hydrogen, all are gas, carbon monoxide, all these are gas, this is also gas. So initially what is the pressure? Initially is this is the pressure is 0.4, initial pressure right here 0.4 atmospheric pressure. So this will be 0, 0 and 0, and here final pressure that is at 12 minutes. So 12 minutes, after 12 minutes, so it will be your, this will be your P, this will be your P, and this is P, and this will be your 0.4 minus P. Now first order reaction we know very well. So for first order reactions we write that is K is equal to 2.303 divided by T log of A divided by A minus X. And one more thing we know that this is moles is proportional to pressure. So for ideal gas we know very well what is that, that is mole is proportional to pressure. So we can convert this moles into pressure. So here A is suppose A is the mole, so this is the 0.4 atmosphere. Suppose A is lead, this is mole, and it is proportional to how much pressure? 0.4. So what is A minus X? So A minus X will be, this is the A minus X, that is proportional to so how much? 4.4 minus P. So we can put directly this value over here. So let's put it. So now we can put this is the K is half-life they have given here. So again half-life is 14.5 minutes. So we can put this K. So this implies that 0.693 divided by 14.5 half-life equal to 2.303, and time is given here 12 minutes, and log of A minus X. So A is 0.4. So here you put A 0.4, and this will be your 0.4 minus P. So here we can solve it. We'll get P equal to 0.175 atmosphere. Now we have to calculate total pressure. So pressure of ether decomposed, decomposed, it will be how much? So it will be 0.175. This is the pressure of the ether decomposed, and total pressure will be, how much? So pressure total will be, you can see we have to add all these things. If you add all these things, it becomes 0.4 plus 2P. So 0.4 plus 2 into, we can write here 0.175, and here we get pressure total will be equal to 0.75 atm. So this is our answer. The decomposition of a N2O5, that is this given 4NO2 plus oxygen, is a first order reaction. After 30 minutes from the start of the decomposition in a closed vessel, the total pressure developed is found to be 284.5 millimeter. So this is 5 millimeter of mercury, and on complete decomposition the total pressure is 584.5 millimeter of mercury. Calculate the rate constant of reaction. So here again we have to find the A divided by A minus X. So we know A, how much A is there. So first you write this equation, 2 into N2O5, this will give you 4NO2 plus oxygen. Now mole at, if you take it initial moles, this is given here A, this will be your 0, 0, and again if you take T equal to 30 minutes, so this will become your A minus X, and this will be your 2x, because if you don't take 2, this will become your 2NO2, this will be half, so this will become your X by 2, so this becomes your X by 2. Now again, so this will becomes at t equal to infinity, if you take t equal to infinity, this becomes your 0 and this becomes your 2 into a, and this will be your a by 2. Now number of mole is proportional to pressure, that we already know. Pressure developed, this we know very well from the ideal gas equations. Okay, so we can write here A is proportional to pressure. A is proportional to pressure. Then what happens? And A plus 3x by 2. So we can write here, so 2x plus x. Now we can write here A plus 3x by 2. So how 3x by 2? So this we know, we can calculate here. So A minus x plus 2x, so x plus 2x, this becomes 3x plus 2. So we can solve here a plus x by 2, so this will becomes 3 by 2x. So we can solve here. This is proportional to how much? So 284.5. so this is equal to t equal to 30. This is given here, 284.5. so only this place is given here. So we can write again, if you take t equal to infinity, so in this case what will happen? Again 5a by 2. So this you will take 5a by 2 is proportional to 584.5 by 5. So this is given here into 2. So here this is the pressure. So this is the 5. Yes, this 5 by 2 by 2 is not this one. This is the 5a by 2 is equal. This is the pressure they have given here. So take this one, and this one. So this is the millimeter. This is the millimeter given here. So from here a we can take it out. From here a is equal to 2 by 5 into 584.5. So you will get here a is proportional to 233.8. so why I am writing this will be useful, because we have to calculate this one. Now to write here this side, keep here. Now x is equal to proportional to 33.8. so how 33.8? so we can calculate here. So this is a plus 3 by 2x is this much. So that is proportional to, this is proportional to this one. So already we know this one, a we know this one. So putting this a value, we can find the value of x here. So x is this much. So a minus x will be how much? So this will be proportional to 200. Okay, so we got x, we got a minus x. Now we can put this value, k is equal to 2.303 divided by t and log of a by a minus x. So we can put that value 2.303 and time is already given. So calculate the rate constant of the reactions. So this is 30. This is log of divided by a. So a is given how much? So a is again we calculated, that is 233.8. so this is the a value. So here you put the a value here, 233.8, and a minus x is 200 divided by 200. So on solving we will get here 5.206 into 10 to the power minus 3 per minute. So this is the answer. Some phosphine is introduced into a flask at 600 degrees centigrade containing an inert gas phosphine. Proceeds to decompose into P4N hydrogen and the reaction goes to completion. The total pressure is given below as a function of time. So with respect to time, this is the total pressure given here. Find the order of the reaction, calculate the rate constant. So we have to write these questions in some detailed way. So here it's 0, 60, 120, infinity, 4 values given here. So we have to find for 4 values for each pressure. Okay, so these are the values. So here 4 pH3 gas plus inert gas, this will give you P4, and here 6 hydrogen gas. So we have calculated value plus here inert gas. So inert gas here, if you take t equal to 0, so this will be your P, this will be your P dash, this will be your 0. This is the gas also, phosphorus gas. So all will be 0 0. Now if you take here T equal to T time, this will be your P minus A, this will be your P dash, this will be your A by 4, this will be your 6 by 4 into A, and this will be your P dash. This is a T equal to infinity, this will be 0, this will be your P dash, this will be your P by 4, this is your 6 by 4 into P, this is your again P dash. Now again T is equal to 0, then P is equal to how much? P will be equal to 642.4. This is equal to P of phosphine gas plus this is the P dash. P dash means inert gas. Again, if you T equal to 60, if you take this, P equal to 272.9. This will equal to P phosphine left. This is equal to P of P4 gas plus P of hydrogen gas and P of inert gas. Okay, then again we have to take 4 value. We have to take T equal to 120, then P equal to 275.51, then again P phosphine left plus P left plus P hydrogen left plus this one. Again if you take T equal to infinity, then P is equal to 276.4, then this is equal to P4 pressure of P4 gas and plus pressure of hydrogen gas and plus pressure of inert gas. So now here we can calculate what we calculate. So P by 4 plus 6 by 4P, and plus we can calculate, we are taking the T equal to infinity, this one T equal to infinity we are taking. So here total pressure will be how much? This is P dash is equal to 276.4, already which is given here. So now if you calculate it, it becomes 7P plus 4P dash is equal to 276.4 into 4. Also if you take it also at T equal to 0, then P plus P dash is equal to 262.4. so this is given here. So here we will get P equal to how much? P equal to will be 18.66 millimeter and P dash will be equal to how much? 243.74 millimeter. So this will get answers. Now we have to find that at T equal to 60 and at T equal to 120. So now if you see here, at T equal to 60, so pressure is how much? So pressure will be your 272.9. so if you go P minus A plus P dash plus A by 4 plus 6 by 4 into A, so it is given here. I am just showing again. So this is the T equal to 60, this value, P left pressure of the P4 and P dash. So this I have taken here. So this is this value. So 60, this is given here. Now this is given to 72, so we can write 272.9 equal to 18.66 minus A, and this is becomes your 243.74 plus 7 by 4 into A. Now here we will get A equal to 14 millimeter. So here K is equal to 2.303 divided by this is equal to 60, and log of this will be your PPS3 at 0. So log of phosphorus will be how much? 18.66, and divided by this will be your 18.66 minus 14. This we are taking like this one, log of phosphine at 0, and here log of phosphine at 60, because we are calculating at 60. So on solving you will get here K value is equal to 2.31 into 10 to the power minus 2 seconds. So this is our K at 2 equal to 60. Now we have to find out K is equal to at T equal to 120. So in this case pressure is how much? 275.51. so again P minus A dash, if you see here T equal to 120. so this is the equations, this one equation and this is the equation. P phosphine left plus P4 P inert gas, T equal to 120. So we have to take this value. So this value I am taking here. So 275 P minus P A dash plus 243.74 plus 7 by 4 into A dash. So here what will happen? So this is equal to 275.51 and P is initial pressure, that is 18.666 minus A dash plus this will be equal to how much? 243.74 and plus 7 by 4 into A dash. So this is the equations. One problem here, 275.5 P minus A, and this will be your, here you cut it by mistake, I have written this is your P dash, here you write here A dash by 4 and plus 6 by 4 A dash. So if you solve it, you will get here these equations. Okay, and P dash is this one, P dash are not, this is an inert gas. So on solving here we will get A dash is equal to 17.48 millimeter. Now K is equal to how much? So K is equal to 2.303, this divided by 120 log of, so A is given here 18.66 initial pressure, it's divided by 18.66 and this is the 17 decomposed gas 48. So on solving here you will get again the value of K will go 2.3 into 10 to the power minus 2 seconds. So we can compare this value and this value. If the K is same, this means that this reaction is, it is the reaction is first order. The reaction is first order. So we got this answer. Catalytic decomposition of the nitrous oxide by gold at 900 centigrade at an initial pressure of 200 mm was 50% in 53 minutes and 73% in 100 minutes. What is the order of reaction? Calculate the velocity constant. How will it decompose in 100 minutes at the same temperature but at an initial pressure of 600 mm? So again we will solve here. So for first order reaction is how much? So K is equal to 2.303 divided by T log of A minus X. So now we have taken case 1. Case 1 is equal to A is proportional to 200 millimeter. So here X is proportional to 200 into 50 by 100. So, or we can say X is proportional to 100 millimeter. So here T half is equal to 53 minutes. So K1 will be equal to how much? 2.303 and divide by 53 log of 200 minus 200 minus 100. So you will get answer 1.307 into 10 power minus 2 minutes. This will be your first case. Now we will do for the second case. So case 2 will be your, here A is again given to 200 millimeter, but again X is how much? Proportional to 200 into 73 by 100. So here because 73% is given, if you see here 73% given, so here we can write here X is proportional to 146 millimeter. So now T 73% is equal to 100 minutes, it is already given here. So K2 will be how much? K2 will be 2.303 divided by 100 log of 200 minus 146. So we have to subtract this one. So on solving you will get here 1.309 into 10 to the power minus 2 minutes, that is the per minute. Now on question 1, so this is the case of what? If you see this value, so previous value was also 1.37, we can see here this also 7. So actually this is the first order by seeing the K value. So it is the first order reaction. Now second is the, what is the average case? So K1 plus K2 divided by 2. So we can divide it 1.307 plus 1.309 divided by 2. So you will get here multiplied by 10 power minus 2. So you will get answer 1.308 into 10 to the power minus 2 per minute. Now third is T, that is 1 by N is proportional to A to the power N. So this reaction proceeds to 73% completion 100. So this reaction will proceed to 73% completion in 100 minutes if initial pressure is 600 millimeter. So this is our answer, because this is dependent on the A. The decomposition of Cl2O7 at 400 Kelvin in the phase, in the gas phase, here it will be gas phase, to Cl2 and O2 is of first order. After 55 seconds at 400 Kelvin, the pressure of Cl2O7 falls to 0.062 to 0.044 atmospheric pressure. Calculate the rate constant pressure of the Cl2 after 100 seconds. So this is our 100 seconds. So again, first you write the equation Cl2O7, it will give you Cl2 plus O2. So O2 is nothing but the 7/2. So mole at T equal to 0 will be how much? This is your A, this is your 0, 0, and this will be your, if you take T equal to 55 seconds, so here mole will be A minus X, this is your X, this will be your 7/2 into X. Now question 1 is, if A is proportional to how much? 0.062. So this is the pressure is given. So how much? A minus X will be proportional to 0.44. So for first order we can write here, this is the first order reaction. So K is equal to how much? 2.303 divided by T, and here log of A divided by A minus X. So we can put this value. On putting this value 2.303, so time is given here 55 seconds, because T is 55. We are calculating T is 55, and here log is given 0.062. So 0.062 divided by A minus X, that is the 0.044. This is the A minus X value. So we can put this value over here. So here we will get, this is on solving, 6.23 into 10 to the power minus 3 per second. So this is the answer. Now second part is that, so if T is equal to 100 seconds, so what will happen? So A by X is proportional to P. A by X is proportional to P. So we can write here 6.23 into 10 to the power minus 3 this seconds. This is equal to 2.303 divided by 100 and log of 0.062 divided by P. So on solving we will get here P is equal to 0.0033 atmospheric. So this is the pressure after 100 seconds on solving this equation.